Welcome back. Let's talk a little bit about ion formation here. So an ion is an atom that's gained or lost an electron to become a charged particle. Remember, an electron is negatively charged, so when you lose an electron, lose something negative, it becomes a positive ion or a cation. A negatively charged ion has gained an electron, it's gained something negative, and it's called an anion. We can see this best by looking at a couple Bohr models. So here's a Bohr model for a sodium atom, electron configuration of 281. When it loses one of its electrons, that outer ring remains empty. Okay, so that third ring is still there. Perhaps you want to draw it on your picture. And it's lost that electron. And it now has a positive charge. In other words, it has 11 protons still. It's still sodium, but only 10 electrons. And for a Bohr model for an ion, we indicate it with brackets, and then we put a plus sign outside the brackets. Similarly for fluorine, fluorine has 9 protons, 9 electrons, electron configuration of 2, 7. It gains an electron in that second ring to have 8, and becomes 2, 8. Now has 10 electrons and 9 protons, so it has an overall charge of minus, and again we use the brackets in the Bohr model when we have an ion. Now, we talked about atomic radius, which is the distance from the outermost electron. Radius is the same thing, but for an ion. You draw a Bohr model for a sulfur atom and a sulfur ion. Right now, this is showing just 2 sulfur atoms. To make the second one a sulfide ion, I would have to add 2 electrons in the outermost ring. Now, this would be an S2- ion. Which radius is bigger? Let's think about it for a minute. So this one has 16 protons and 16 electrons. This one has 16 protons and 18 electrons. That means these electrons in this outermost ring can get a little bit further from the positive center. So this radius would be larger than the sulfur atom. This summarizes that idea and the idea of a positive ion. For a positive ion, the radius is going to be smaller. Think about it. In a positive ion, you've lost electrons. You can think back to the sodium example. Right? Lost this electron here, so now that radius is smaller because the radius is only from the center to the outermost electron here. Let's practice this a little bit with our claim evidence reasoning. So here would be an example. The claim is that Mg2+ has a smaller radius than Mg. The evidence would be those values that you could look up. What would be the reasoning? The reasoning would talk about the chemistry. The reasoning would say something like this. Mg2+ has the same number of protons as Mg, but fewer electrons. And these electrons, the electrons in Mg2+, closer to the nucleus. Let's see how that sounds. Mg2+, we want to make that an exponent, has the same number of protons as magnesium, but fewer electrons. And the electrons in Mg2+ are in a ring closer to the nucleus compared to Mg, making the radius smaller. That would be a pretty good reasoning example. How about this one? Which would you expect to have a smaller ionic radius, Na+ or Mg2+? This one's a little bit trickier because both sodium and magnesium are in the same period. Let's start with the claim. Mg2+ has a smaller radius than how about the evidence? Well, we have the radius of Mg2 plus here, 72 picometers. So Mg2 plus has a radius. And I looked up Na plus before starting this video, and it has a radius of 95 picometers. Now we have to try and explain why. To explain why, we got to think about both the number of protons and electrons, right? So both Mg2 plus and Na plus have Mg2 plus has 12 protons, while Na plus has 11 additional proton. Pull the electrons in further, giving Mg2 plus a smaller radius than Na plus. That would be a pretty good reasoning example for this one. One other thing we want to talk about the ions is something called their noble gas configuration. So, oftentimes when an atom loses an electron or gains an electron, we tend to talk about what noble gas has the same electron configuration. So, for example, when sulfur is originally 286, but when it gains 2 electrons to become 288, we say that it has the same electron configuration as argon. So therefore, a sulfide ion, 288, has the same noble gas configuration as argon. How about this one? The electron configuration of magnesium ion is the same as which noble gas? Well, magnesium is normally 282. But when it becomes an ion, it's going to lose these 2 electrons to become 28. I look on the periodic table and I see neon has an electron configuration of 28. How about what ions have the same electron configuration as argon? I'm going to want to look at argon on the periodic table and then find the ions that are near it that have an electron configuration close to argon's configuration of 288. Well, chlorine is 287, so when it becomes a Cl- ion, it becomes 288. That would be a great option. Other options would include sulfide and phosphide. Don't forget about the positive ions. A sodium atom is normally 2881, but when it loses that 1 electron, it becomes 288. The same thing with calcium, normally 2882, becomes 288, the same configuration as argon, when it loses 2 electrons. Next, we're going to talk a little bit about writing charges and eventually work our way towards writing formulas.